Okay, continuity. So continuity is attached to limits. Um, let's take a look at a couple ganders. We have a three-part proof for continuity. So for continuity, oh, actually, let me first write this. So continuity, we will have a function, right? And then we'll have an x value, like x equals 1. Okay. So the question for us for continuity will be, is the function f of x continuous at the point x equals 1? Okay. So to solve this, we do a three-part proof. First part is, does f of a exist? Okay, so we need to solve that. Does f of a exist? Second part, does the limit as x approaches a of f of x exist? Okay. And then the third part, does the number we got for number 1 equal the number we got for number 2? Okay, so does the limit match with f of a? All right, so let's try a quick little practice. We have f of x equals x squared as at the point x equals 1. So my first step here is, does f of a exist? So f of 1 for x squared would be 1 squared. Boom. Easy. Number 2, does the limit as x approaches a for f of x exist? So the limit as x approaches 1 for x squared would be what, right? Our first step of limits, plug it in. Boom. It exists. Number 3, does my f of 1 match my limit as x approaches 1? Yes. 1 does in fact equal 1. So I would now finish this out by saying continuous at x equals 1. Nice. Okay, now let's try a harder one. Let's say f of x is x squared minus 4x plus 2. And I'm solving for the point x equals 2. My first step is plug it in. So f of 2 is 2 squared minus 4 times 2 plus 2. Right? This will give you negative 2. So f of a does exist. It's good. F of 2, as the limit of x approaches 2, we would get the same thing, right? We plug it in. Negative 2. Awesome. Do these two match? Yes. So continuous at x equals negative 2. Okay. Now the tricky stuff here is that, I mean, typically this first step will not be too hard, where you just plug in your f of a. But the limits, right? The problem here is that depending on what you're getting for your limit, you might have to do factor FOIL, step 2 of limits, remember? If you get 0 over 0, you might have to factor FOIL simplify and redo it. So that gives you a little extra work. Or if you get the third step of limits, a number over 0, square root of 0, right? Absolute value over 0. If you get one of those, then you'll have to do left and right hand limits. And then these two have to equal together to give you your final limit. And then only if your final limit matches f of a can you say that your function is continuous at the spot. Okay, so that's a very extreme case, probably something that'll be on the quiz because it's fun. But right, there can be a lot of layers for our continuity check. But so far, that's it. Why don't we slide over to, because this is continuity, we'll slide to discontinuous, right? How do I know a function is discontinuous? There are different types. Honestly, I think I'm going to leave you guys to find that or study up on your own for that. Go to your packet. There's also everything's uploaded on Learn at VCS. But the type of question we would see on the test or the quiz is that I'll give you a function like this, and then you're going to have to tell me the type of discontinuity. So you'd write that down like, oh, Mr. O, that's a jump discontinuity. And I'd be like, great job, man, little kid. And you're also going to have to tell me where that discontinuity is located. So located at, let's say in this case, maybe we had something that was like blah, 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 over x plus 3, right? The top doesn't matter in this case. It's just that what value of x do we have a 0 on the bottom? And you guys hopefully know that this would be -3. So we would have a infinite discontinuity at x equals -3. How exciting. Okay, so that one's not the worst. That one, you're just going to need to know your vocab and how to do some algebra. So please look at that little master sheet from our notes that talked about discontinuity.